Welcome to Data to Intelligence, your go-to channel for transforming raw data into meaningful insight. Azure Data Lake Storage, ADLS, Gen 2 storage accounts. The target path can point to any folder within the hierarchical namespace. At a minimum, the target path must include a container name. ADLS shortcuts support the following delegated authorization types: organizational account, must have storage blob data reader, storage blob data contributor, or storage blob data owner role on the storage account. Service principal and workspace identity, must have storage blob data reader, storage blob data contributor, or storage blob data owner role on the storage account. Shared access signature, must include at least the following permissions: read, list, and execute. Account key, the storage account access key. Account keys grant full access to the storage account, so use this option with caution and protect your keys appropriately. Shortcuts in Microsoft OneLake unify your data across domains, clouds, and accounts by making OneLake the single virtual data lake for your entire enterprise. Fabric experiences and analytical engines can connect to your existing data sources including Azure, Amazon Web Services, AWS, and OneLake through a unified namespace. OneLake manages all permissions and credentials, so you don't need to separately configure each Fabric workload to connect to each data source. Additionally, you can use shortcuts to eliminate edge copies of data and reduce process latency associated with data copies and staging. Shortcuts appear as folders in OneLake, and any workload or service that has access to OneLake can use them. Shortcuts behave like symbolic links. They're an independent object from the target. If you delete a shortcut, the target remains unaffected. If you move, rename, or delete a target path, the shortcut can break. Shortcuts appear as folders in OneLake, and any workload or service that has access to OneLake can use them. Shortcuts behave like symbolic links. They're an independent object from the target. If you delete a shortcut, the target remains unaffected. If you move, rename, or delete a target path, the shortcut can break. We can create shortcuts in Lakehouses and Custo Query Language, KQL, databases. You can use the Fabric portal to create shortcuts interactively, and you can use the REST API to create shortcuts programmatically. When creating shortcuts in a Lakehouse, you must understand the folder structure of the item. Lakehouses have two top-level folders, the Tables folder and the Files folder. The Tables folder is for structured datasets. The Files folder is for unstructured or semi-structured data. In the Tables folder, you can create shortcuts only at the top level. OneLake doesn't support shortcuts in subdirectories of the Tables folder. Shortcuts in the Tables section typically point to internal sources within OneLake or link to other data assets that conform to the Delta table format. If the target of the shortcut contains data in the Delta Parquet format, the Lakehouse automatically synchronizes the metadata and recognizes the folder as a table. Shortcuts in the Tables section can link to either a single table or a schema, which is a parent folder for multiple tables. In the Files folder, there are no restrictions on where you can create shortcuts. You can create shortcuts at any level of the folder hierarchy. Table discovery doesn't happen in the Files folder. Shortcuts here can point to either internal OneLake and external storage systems with data in any format. Any Fabric or non-Fabric service that can access data in OneLake can use shortcuts. Shortcuts are transparent to any service accessing data through the OneLake API. Shortcuts just appear as another folder in the lake. Apache Spark, SQL, real-time intelligence, and analysis services can all use shortcuts when querying data. Apache Spark notebooks and Apache Spark jobs can use shortcuts that you create in OneLake. Use relative file paths to read data directly from shortcuts. Additionally, if you create a shortcut in the Tables section of the Lakehouse and it is in the Delta format, you can read it as a managed table using Apache Spark SQL syntax. The shortcut can point to a folder location within the same item, across items within the same workspace, or even across items in different workspaces. When you create a shortcut across items, the item types don't need to match. For example, you can create a shortcut in a Lakehouse that points to data in a data warehouse. When a user accesses data from another OneLake location through a shortcut, OneLake uses the identity of the calling user to authorize access to the data. This user must have permissions in the target location to read the data. Use relative file paths to read data directly from shortcuts. Additionally, if you create a shortcut in the Tables section of the Lakehouse and it is in the Delta format, you can read it as a managed table using Apache Spark SQL syntax. You can read shortcuts in the Tables section of a Lakehouse through the SQL Analytics endpoint for the Lakehouse. You can access the SQL Analytics endpoint through the mode selector of the Lakehouse or through SQL Server Management Studio, SSMS. In this section, we use the copy data activity to ingest sample data from Lakehouse to warehouse. In the workspace you created in the previous tutorial, select New Item. Select the new copy data activity from the canvas. Activity properties appear in a pane below the canvas, organized across tabs including General, Source, Destination, Mapping, and Settings. You might need to expand the pane upwards by dragging the top edge. On the General tab, enter Data Copy to Lakehouse in the name field. Leave the other fields with their default values. Copy Job is the go-to solution in Microsoft Fabric Data Factory for simplified data movement from many sources to many destinations, no pipelines required. With native support for multiple delivery styles, including bulk copy, incremental copy, and change data capture, CDC, replication, Copy Job offers the flexibility to handle a wide range of data movement scenarios, all through an intuitive, easy-to-use experience. Whether you're new to data integration or just want a faster way to get your data where it needs to go, Copy Job offers a flexible and user-friendly solution. Some advantages of the copy job over other data movement methods include, easy to use, set up and monitor data copying with a simple, guided experience, no technical expertise needed. Efficient, copy only new or changed data from the last run to save time and resources, with minimal manual steps. Flexible, choose which data to move, map columns, set how data is written, and schedule jobs to run once or regularly. High performance, move large amounts of data quickly and reliably, thanks to a serverless, scalable system. You can choose how your data is copied from source to destination. Full copy. Every time the job runs, it copies all data from your source to your destination. Incremental copy. The first run copies everything, and subsequent runs only move new or changed data since the last run. In incremental copy, every run after the initial full copy, called a subsequent load, transfers only certain changes. Copy Job automatically tracks and manages the state of the last successful run, so it knows what data to copy next. Copy Job supports watermark-based incremental copy, such as row version, datetime, date, string interpreted as datetime, and integer columns, and CDC-based incremental copy when CDC is enabled on the source. If a copy job fails, you don't need to worry about data loss. Copy Job always resumes from the end of the last successful run. A failure doesn't change the state managed by Copy Job. You can also reset incremental copy back to a full copy at any time, either for the entire job or per table. Use CDC-based incremental copy when CDC is enabled on your source and supported by the Copy Job connector, and you need to replicate inserts, updates, and deletes, keep the destination continuously in sync, support SCD Type 2 history, or minimize scan load on high change volume tables. Use watermark-based incremental copy when CDC isn't available on your source but your table has a reliable incremental column, for example, row version, datetime, date, integer, or string interpreted as datetime, and you only need to track inserts and updates. You can copy subsets of data from your tables using database queries, which unlocks a wide range of data ingestion scenarios. This capability supports both full and incremental copies on table subsets based on your custom queries, which lets you flexibly select and filter data before loading. Your data ingestion becomes more efficient, precise, and tailored to your needs. You can also decide how data is written to your destination. By default, Copy Job appends new data, so you keep a full history. If you prefer, you can choose to merge, update existing rows using a key column, overwrite, replace existing data, or SCD Type 2, preserve change history with effective dating. If you select Merge or SCD Type 2, Copy Job uses the primary key by default, if one exists. When copying to a database, new rows are added to your tables. For supported databases, you can also choose to merge, overwrite, or use SCD Type 2 for existing data. When copying to storage, new data is saved as new files. If a file with the same name already exists, it's replaced. When performing an incremental copy from the source and merging into the destination, rows from the source are inserted or updated in the destination. When performing CDC replication from the source and merging into the destination, rows from the source are inserted, updated, or deleted in the destination. When using SCD Type 2 with CDC replication, changes are preserved as versioned rows with effective dating, and deletes are handled as soft deletes. Copy job can automatically create tables in the destination if they don't already exist. If the destination tables are already available, you can simply select them as your target. With flexible column mapping options, you can easily define how to map schemas from the source tables to the destination tables. You can also optionally truncate destination data before the full load, ensuring their source and destination are fully synchronized without duplicates. By default, copy job does not delete any data in destination. When you enable this option, the first run of incremental copy will truncate all data in the destination before loading the full dataset. Subsequent incremental copies will continue to append or merge data without affecting existing records. If customers later reset incremental copy to full copy, enabling this option will again clear the destination before loading. This approach ensures that your destination remains clean, fully synchronized, and free of duplicates, providing a reliable foundation for their data ingestion solution. If you only need to copy your data and don't need transformations, a copy job might be a better option for you. Copy jobs provide a simplified experience for data movement scenarios that don't require creating a full pipeline. The copy job activity runs a copy job directly inside a pipeline. This means you can manage data movement alongside other tasks like transformations and notifications, all in one place. Copy jobs move data from your source to your destination with flexibility and ease. You can use full copy or incremental copy behaviors. In incremental copy, every run after the initial full copy, called a subsequent load, transfers only certain changes. Copy job automatically tracks and manages the state of the last successful run, so it knows what data to copy next. When copy job copies from a database using an incremental column, watermark column, each subsequent load copies only rows with a value in that column larger than any row previously copied. When copy job copies from a database that has CDC enabled, each subsequent load copies all rows inserted, updated, or deleted since the last successful run. When copy job copies files, each subsequent load copies only those files created or modified since the last successful run. If your database has CDC enabled, you don't need to choose an incremental column. Copy job automatically detects the changes. See more details for change data capture, CDC, in copy job. If a copy job fails, you don't need to worry about data loss. Copy job always resumes from the end of the last successful run. A failure doesn't change the state managed by copy job. Copy jobs move data from your source to your destination with flexibility and ease. You can use full copy or incremental copy behaviors. Watermark-based incremental copy is a good fit when CDC isn't enabled or isn't available on your source database, or you can't enable it because of permissions, licensing, or source system constraints. Your source table has a reliable incremental column that increases monotonically whenever rows are inserted or updated. For supported types, see supported watermark column types. You only need to track inserts and updates, not deletes. Watermark-based incremental copy can't detect rows that are deleted from the source. You're copying files based on their last modified date. File-based incremental copy uses the file modification timestamp as the watermark.